So today we've got an opportunity to look at a soil pit in the Finniss region on the Fleurieu Peninsula. We're in about a 550 mil rainfall area, and currently this field's been set up for pasture production, so more beef cattle and rotating through with some poultry and sheep as well. So really good opportunity to understand what some of the complexity is with these soils around this Finniss region, which is still representative of other areas in the Fleurieu Peninsula and around South Australia, and how we can be understanding these profiles for where to capture opportunities for increasing productivity, improving drainage and overall capacity to support the landscape function and overall soil's capacity in general. So the soil type we have here today is what's called a chromosol. So a chromosol is a texture contrast soil, and texture contrast, what is that? So texture contrast, exactly what it sort of sounds, is two differing textures overlying one another. So here we have a sandy textured soil overlying a clay textured subsoil. So really fine textured clay, and it's the history of the landscape. A lot of glacial impact which has influenced the geology and overall soil types of the region, but we've got sandy upper profile, so really high concentration of sand in the 0 to around 60-70 centimeters, and then below that we've then got the clay content increasing. So when we're looking at a soil profile, we're again looking for the number of layers that are in the soil. So they're what's called soil horizons. So if you're doing further research on what some of your soil layers mean, that soil horizon is another term that might be used. So we want to see what layers are in here, and the soil colour is a great starting point for that, and also looking at how the plants are behaving in this profile. So in this 0 to sort of 15 centimetre area of the profile, we've really got highest concentration of root material. We've also got a darker grey coloration in this soil. Then down around this sort of 15 centimetre mark, we start to see a colour change, and the content or the volume of roots decreases slightly compared to what's above, but we've still got some root activity in that layer. Then down around that 30-35 centimetre mark, we're seeing another colour change. So this is quite a white sand in this second layer. We've got a bit more colour of yellows and oranges coming into this sand, sitting in that 35 to around the 65-70 centimetre mark. As we go down into that next layer, we do have an increase in that clay content, as I was touching on earlier. So that's really influencing how this soil is draining as well. So remembering we're in that sort of 550 mil rainfall area, and also we're on a lower slope currently. So significant slope coming from above us and then heading down to some lower flats, which is then has presence of a lagoon there as well. So we know there's quite a lot of excess water in this landscape. So in this subsoil, there's a lot of colour change that's occurring. So we've got what's ultimately a reddy orange clay subsoil that has got a lot of greys in through it as well. And as soon as we see multicoloured subsoil, it tells us a lot around how much moisture that's holding in that subsoil for prolonged periods of the year. So there are processes that happen in the soil when, depending on the amount of oxygen that's in the soil. So soil colour is governed by the oxidation state of iron, or how many positive charges essentially iron's got on it. So when you see a red colour in soil, you think how rusty that iron is. So we've got plenty of oxygen. When it goes grey, we've got a reduced form of iron, and it means it's been in more anaerobic conditions. So when we've got that mix of reds and greys together, it tells us there's been imperfect drainage or prolonged moisture holding in that soil. So something to think about of saying, well, what's happening in this landscape? Where's rainfall going to, and how is it potentially draining off the landscape, and how are the plants going to behave in this profile as the roots go exploring down through the soil? So what are some of the challenges with a soil profile like this? Remember, we've got a sandy upper profile sitting over that clay subsoil. When we look at a sandy soil, we've got to think of it, when we think of soils, we kind of think of them like a size of a battery. And when you think of a sandy soil, we've got to be thinking more like a AA battery. So smaller battery, doesn't have the huge amounts of reserves in it. Where when we look at a clay soil, you want to be thinking of like a truck battery. So we've got huge amounts of reserve that's there to provide back to the soil system. So as we go down through this profile, we can see that when the plants are trying to get going and accessing some early nutrition, we've got a sandy soil that's relying heavily on organic matter for that nutrient cycling, and then we run into some layers where there's very low nutrition in those layers. That's when we need to be thinking about how can we supplement the fertility program in this field. And then as we go down into that subsoil, we've got higher clay content. With clay comes more nutrients. So there'll be a greater pool of potassium, magnesium, some calcium, maybe some sodium as well. But that's potentially happening quite late in the season by the time the roots are getting down to that layer. So this is really important to think what is going on with, if we were to do a soil test in that 0 to 10 centimetres, it actually doesn't mean a huge amount once those roots are out of that zone and growing down into that next layer. So in an ideal world, I'd love to get at least 3 soil tests from down this profile to see what is that nutrient availability trend down through those layers, how much does my pH change, and there are simple field tests we can do for pH to quickly identify have we got acidic or alkaline pH in these soils. So some really simple tools to just get you thinking around how would we maybe structure our decisions around planting a new pasture or choosing whether we should go in with a crop or like, is this soil type suitable? That's the critical question to be asking whenever we're having a look at a soil profile. When we deal with sandy soils, another key thing to think about is when you've got high concentration of sands, they're very prone to what's called non-wetting or being hydrophobic. So that's when the soils just don't love having water going into them, which quite often seems counterintuitive because we're relying on rainfall to fuel these soils, but we can go through periods where the soil is quite hydrophobic. Once the soil wets up, some of that hydrophobicity or that non-wetting tendency is diminished, but it really can be a factor that can influence the capacity for plants to germinate, especially if you're going in shallow with pasture seeders, and dropping that seed into a non-wetting layer can have significant issues on that capacity for that seed to strike and get a good germination. So a way we can assess if we do have non-wetting in our soil or hydrophobic tendencies is to collect a sample of the soil and quite simply just add water to it, see how it behaves. So we can just grab a bit of soil from the upper part of the profile, and generally the closer the soil is to the soil surface, the more prone that soil will be to non-wetting, especially if it is a relatively pure sand. Then all we need to do is pour a little bit of water, make a little bit of a well in the middle, and then if we pour a little bit of water in there, we'll see that ponding on the surface, and then we can see assess the time for that water to infiltrate into that sample. So the longer that water takes to actually wet that soil, the more hydrophobic that soil is, and then you can track that over time to say, does that diminish? There are other tests you can also do, one called the molar ethanol droplet test. Quite simply in the field, using some water and timing how long that water is taking to get in is a really simple way to assess the amount of non-wetting or hydrophobic nature of that soil. So another test we can do, once we know what our layers are, that's a really good opportunity to do some in-field pH tests. pH is a really handy tool that we can do measurements in the field to assess what that variation in pH might be. pH is a great indicator for understanding your capacity to cycle nutrients, so how active the biology might be in a certain layer, as governed by that pH, also the nutrient availability, and potentially if you're going to be running into any other constraints, which might be something like aluminium or iron in your more acidic soils, or might be something to do with more alkaline soils like carbonate or bicarbonate, which is also causing some nutrient lockup and lack of availability. So pH can be a really handy tool for that. So there are simple field pH kits which you can get from your local hardware store, which are really suitable for assessing how your pH is situated in the field. All I've done as I've gone down through this soil profile is grab a little bit of a sample out of each of the layers and laid them out. One, it helps give a great representation of what the different layers are down through the profile, but also make it easy to manage on how we're assessing these samples. Then in the kit, you'll have a bit of pH indicator dye as well as some barium sulfate to really highlight what color it's going. Then we add a little bit of the liquid. Again, like we touched on, a little bit hydrophobic here, so might be a little bit difficult to get these top ones to wet up, might just take a little bit of time. Then as we go down, we can see what this color change might be. We'll see as we get down now that soil's wetting up a bit easier again. Then all we do is then add that barium sulfate powder on top. We can give these a little bit of a mix. In the kit, you've got a little bit of a spoon to give it a mix, which just helps some of that indicator get in. Give it a little bit to develop that color, and then in that kit, you'll be then provided with a pH indicator wheel. And all we want to be doing is simply matching up that color with what match the color wheel up with what the soil color has developed to be. So in this profile, sitting relatively neutral around that 6.5 pH in the top two layers, sitting around that 6.5 again in that third layer down, around 6 in that sand sitting above the clays, and then going up to 7 right above the clay, and then the clay is sitting around that 6.5 pH again and below. So overall we do have a relatively neutral profile. In the sandy area where it's a bit more bleached, so lost that soil color relative to the topsoil, we have seen that pH drop, probably about one pH unit less than the layer above. And that's something really to keep an eye on, because that can be a bit of a trap for early root growth, getting down into that layer if we do have that decrease in pH. So it is really worthwhile seeing what that change is. Then that helps you select which samples, especially from your subsoil, might be suitable for sending off for further laboratory analysis. As we go through this pH wheel, what we've got to remember is that it's not just a standard scale of going pH 5 to pH 6 to pH 7. As we're going up that grade, we're actually going up on a logarithmic scale. So each unit, so from going from pH 5 to pH 6 is actually 10 times more alkaline. So going from pH 5 through to pH 7 is 100 times. And quite often in South Australian soils especially, we'll see this change from pH 5 through to pH 8 and further. So that can be up to 1,000 times variation in pH from your topsoil to your subsoil. And that's a really critical factor, and that's what plants have to deal with as they're growing through these soils, and why it's so important to just get a basic understanding of your pH is such a powerful tool to understanding where some of these limitations might be sitting. So if you're wanting more information on soil management, please contact Landscapes, Hills and Fleurieu.